Today we're going to be talking about the measures of variation. You've already discussed the measures of center, which talks about what typically happens near the middle of part of your data. Measures of variation is where you're looking at the spread of the data. How spread out it is. And you want to pay attention when you're doing the measures of variation. You're looking to see how the data is distributed or spread out. Okay? We're going to start out with some vocab like we usually do. There's a lot of vocab in this statistics unit, and measures of variation include a lot of that. Okay, the first thing we're going to remember is that the median divides the data into two equal parts. That's your middle. Okay, once you have the middle, this is a measure of center. We've already talked about that. Once you have your middle, you're going to be able to separate it into four equal parts, which is called quartiles. Okay, the first quartile is called Q1, or the lower quartile. This can also be abbreviated as LQ, and it is the median of the lower half of your data. And you don't include the median when you're finding it. And we'll talk about that a little bit more in a second. The median of the upper half of our data is called Q3. And we call that upper quartile, and you guessed it, we can abbreviate that as UQ, as upper quartile. Again, don't include the median when you're finding the upper quartile, just like the lower quartile. The difference between the highest and the lowest values is called the range. The highest and lowest values are also called the minimum and the maximum. So if you hear both, don't let that bother you. And then here is a crazy word. Well, two crazy words. Interquartile range. Thank goodness we can abbreviate that. We don't want to write that every time. It's abbreviated as IQR, and that is the difference between Q3 and Q1. And again, difference means to subtract. Whenever you have the range of any type, you're going to subtract. Interquartile range is a type of range. Interquartile tells us to take the quartiles and find out how spread out they are, so you subtract the two quartiles. All right, so these words are going to make a whole lot more sense when we actually look at a problem and find them. The set of data we have here goes from 20 to 33. Luckily, it's already in order for the median, because that's what we learned from measures of center. You have to put the median. To find the median, you have to put the numbers in numerical order first. So we did that. Found the median to be 27. Some people choose to call the median Q2. So if you hear that, don't let that bother you. Median is Q2, definitely. When you're calculating the lower and upper quartiles, like I put the little note for you up here, you don't include the median. So you hide the median, and everything above it, that is your lower half. And on the lower half, you find the middle of that to get Q1. All right, well, the median of these four numbers, remember when there's two in the middle, you add them up, divide by 2. Well, the middle of 24 and 24 is 24, and this would be Q1. Add them up, divide by 2. Okay? Same thing over here. Don't include your median. This is the upper half of our data. We're going to find the median of that The middle of 32 and 33 is 32.5, and this would be your Q3. Okay? If you can't do the math mentally between the two numbers, remember, you just add them up, divide by 2, and you'll be fine. Alright, now, we're just going to fill in what we know. The minimum number, which is your smallest, is 20. We call that the smallest. We also could call this the lower extreme. The maximum is our highest, 33, which could be called the upper extreme. I told you, lots of vocab here. Median, we already know, is 27. Q1 we found to be 24. Q3 we found to be 32.5. The range is the difference between the min and max, so we're going to subtract those two. That would be 33 minus 20. Now don't stop there. We need to tell people how far apart they are. So it would be 13. So this is the work to show. Oh, I'm writing away and you can't see a thing. Sorry, guys. This is the work you would show to get to your range. The interquartile range says to subtract your Q3 and your Q1. So that would be 32.5 minus 24. You can do this mentally, but for graded assignments, I would suggest using a calculator to make sure that you're not making a careless mistake. I know we're going to let you use calculators, but check with your teachers. Make sure they're going to let you use it. But no sense in making a careless mistake when you are allowed to use the calculators. All of these are not measures of variation. Technically, there are two measures of variation, and that would be the range and the interquartile range. But to be able to figure out the interquartile range, you have to determine the median, Q1 and Q3. All right, so over here, just some quick little notes to help you when you're finding the range. First, you have to put them in order, just like you do for the median. And you're going to subtract the minimum and maximum. To find the IQR, you're going to subtract Q1 and Q3. All right. Whew, lots of vocab. The next page is where I'm going to have you practice with the quartiles. And I want you to see if you can fill in the blanks up here without looking at the previous page to see if you understand the vocab. So I'm going to let you pause. I want you to pause the video and come back and see if you got the right answers. Welcome back. Take a look and see how you did. Not only is this practicing what the vocab is, it is actually the steps for identifying what the quartiles are. If you need to, pause the video and correct anything you did not get correct. And then we'll move on to some examples. All right. It says that they want us to identify the median, or Q2, Q1, and Q3 of the data set. Well, one thing they did for us here, which is really nice, is they put them in order first. Thank goodness they did that. We did not have to. All right. I like to spread them out because I write really big. So I'm just going to, since it's a short list, I'm going to rewrite it. So we have 3, 4, 4, 5, 6. Oops, I didn't spread out 4, 8, and 8. Notice I marked them out as I went. You can also double check and count how many numbers are in the original list and then how many are in your list. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That way you know you've gotten them all and you haven't left any out. Okay, so we got to find the median. So these two go together, these two go together, these two go together. There is our median. Okay. Well, there we go. All right, we need to find Q1, so hide the median in the upper half of our data. We're going to mark those out. 1 in the middle. Remember, if there's 2 in the middle, average them, add them up, divide by 2. But we didn't have to do that. This is our Q1. And now for Q3, hide the median, and the upper half of the data is here. There is our Q3. Okay, those are what they asked for, and so now we have our 4 sections of our data. Okay, so when you have something in half the halves, that gives you fourths. We have 2 numbers here, we have 2 numbers here, we have 2 numbers here, and there. All right, so we're good to go. What if they asked you to find the IQR? Let's think. What is range? Range says to subtract, interquartile says to subtract the quartiles. So that would be 8 minus 4, which is 4. So that's telling you how spread out the data is for the middle 50% of your data. All right, well, that's all there is to it. We've labeled the pieces. We found out that our numbers for the interquartile range are only 4 numbers apart, so our data is very consistent, has very little variability. That's what it's telling us. All right, I want you to try the next one on your own, so pause the video and come back in just a little bit. Okay, welcome back. So let's see how you did. This one was a little trickier than the previous example that we did together. You had to remember that when there's 2 numbers in the middle, you have to add them up, divide by 2, or this one you could do mentally. Very tricky part right here. Finding quartile, the lower quartile or Q1, because you don't include the median. 28 is not the median. So 28 is included in the lower half of your data. So these 2 would cancel out, these 2 cancel out to find the middle of 21. Same thing happens over here. 30 is not your median, so we have to include it in the upper half of our data to get to 32 as our Q3. All right, I hope you got that. If not, go fix it real quick. You can pause the video and come back. The next thing we need to talk about is sometimes you'll be asked to determine the best measure of variation for your data. Which number typically tells us shows the variation of your data. Okay? What number typically shows how spread out the data is? That's what this is asking you to do. Outliers, just like they drastically change the mean for the measures of center, they drastically change the range. That's very important, guys. Outliers drastically change the range. Okay? Now, an example of that would look like this. If I had the numbers in my data of like 3, 0, 3, 7, 9, 9, and 40. Do you see an outlier? Oops, sorry, you can't see that, can you? We have the numbers 0, 3. Oh, that's not showing up very well. 9, 9, and 40. The range would be from 0 to 40, which is 40. And then the interquartile range, well, we got to find the median. So the median is 8. Q1 is 3, and Q3 is 9. So the interquartile range would be 9 minus 3, which is 6. All right, so these are the actual answers for this set of data. If I wanted to choose which one of these, the range or the interquartile range, typically shows how spread out my data is, then I would definitely not want to pick the range, because it's saying that my numbers are typically spread out a lot as compared to here where the interquartile range is only 6. Had we found the range without that outlier, it would have only been 9. So there wouldn't be much variability in our data. By including the range, it would make you think, oh my gosh, this is really spread out. But typically the numbers are not spread out. There's just this one outlier that's making a big difference. So that's why, for an example on this one, when you have an outlier, you would not want to choose the range. You would want to choose the interquartile range as the best predictor of how spread out your data is. So, quick little note here. When there's no outlier, you pick the range. Just like here. If I did not have this outlier, yeah, the range would be about right. It wouldn't be very spread out. But when there is an outlier, do you see how the range changes so much? That's why you would want to choose the interquartile range to describe the variability of your data. All right, so there's a lot of vocab. Please go back, make sure you study, and I hope this helped.